Okay, so this is the 5th webinar in the series, and today we're going to be talking about automation in the FX80 and in the Tritium system. If we look at our typical Facility Explorer station, so in this case I'm running a station called Training FX80. It's running inside the platform on my Windows PC. So the station is running in Windows, but essentially in terms of a project, when I finish configuring it, I'm going to copy it across and load it into an FX80. So everything I'm doing here today would work as if it was on an FX80. Now, the other thing you can also note is that if I had a FX server, everything I do today could also be done on an FX server. So the server supports automation. So if you had an FX server that's supervising a big, large site of FX80s, and you needed to do some data gathering across all of those FX80s, then you could do that work like a cooling call or a high select, or maybe sharing outside air temperatures. You could do that work in the FX server if that was appropriate. So logic in a Facility Explorer system can exist anywhere on any station. Okay, so looking at our station, we have our tree, and every node on the tree, as we've seen before, we can double click a node and we see a graphic, but we can also see a property sheet, and there's nearly always the option for a wire sheet. So that's the wire sheet for that node there on the tree, the AHU. We double click the points folder. We're looking at the point extension manager. We could just as easily look at the property sheet, or we could look at the wire sheet. Okay. So once we get on the wire sheet, we can start doing automation. So if I wanted to take an input value like the discharge air temperature, I can connect that to any numeric writable point just by dragging and dropping. Okay. So what that says is that I take this output from this point and I connect it to this writable point, and I connect it via a priority connection. So this cooling output here, which is a numeric writable point, can have, there's two inputs available, in 16 and in 10. Okay, so connecting to in 16 means that this value will be written at priority 16. Okay, if I double click and look at my property sheet, you'll notice there's input 9, 10, 11, 12, 13, and so on. In 16 has currently got a value because of that connection that I made. Okay, if I go back, in 15, we can't see it. Okay, if I want to make a connection at priority 15, there's two ways I can do it. I can take my output and just drop it onto the white line there, okay? And this gets me my link dialog, which says I took my output from OAT and I'm going to connect it to my cooling output using priority 15. So output out to in 15. Okay, I go OK, and it makes that connection. And it's made it to input number 15, and all of a sudden 15 is visible. If I right click, delete it, 15 goes away. So that's one way to do it. I drag and then I drop it onto the white. I choose my output and I connect it to input. This time I'll go to input 13. Okay, I've made a connection to input 13. Another way I can expose these inputs for connection is if I select it, right click and pin slots. This last option in the list, pin slots. And it shows all of those inputs, and I can put a pin next to them, which means they'll now be displayed. Okay, and now I can make a connection. I can come out of here, go into there. I can come out of here, go into there, and so on. And you'll notice another thing that happened there. It automatically draws the line. And if I relocate this, it'll possibly draw that line. So that line has now been drawn. If I move it to a point where it can't draw the line anymore, it's too complicated, it'll just draw a little dot. I select that dot and I can see where the other end of that connection is. So whenever you see a little dot like that, it means that there's a connection. Okay, and everything on the right-hand side is a connection going out. Anything on the left-hand side is a connection coming in. So selecting that. Now, if you look down here at the bottom left-hand corner of the status bar, when I put my mouse over that connection, it will show you the connection details. It'll show you that I'm coming from the DASP out and I'm going to cooling 0 in 14. Okay. So that's how you make connections in a wire sheet. You start at an output, you drag it, and then you drop it onto an input. Okay. If the input you want is not available, you come out and you drop it onto the white, and you get the option of making a connection to the various input slots on the output. Okay, so I'm coming from there, and this time I'll go to the fallback. Go OK. All right. So this is all doing logic inside the points folder of an AHU controller on a backnet network. Okay, so all of this logic will execute at the FX80. Okay, and the result will, all of it currently will result in a command being sent to this numeric writable point on the backnet controller. Okay, and whatever is the highest priority is the command that will be sent. So at the moment, this connection here is the only connection that matters. Okay, so if I take that connection out, the next connection that matters is in 13. Okay, if I take him out, the next one is in 14. If I select that, it highlights the other end of that connection. I can right click and delete. That connection's gone. Now we're back to in 15. I can delete that. Now the one that matters is the in 16. I'll delete that. Now the only one that matters is the fallback coming from here. I'll delete that. Okay. So delete this connection. Now I'm back to where I started. All right. So you can have a wire sheet anywhere on the tree. So if I go to the level 1, I can view the wire sheet for level 1. And underneath there, you'll see all of the folders. So they're automatically lined up like this, but I can relocate them so that I can see the individual controllers. And just say I wanted to high select the zone temperatures. Okay. So I've got my level 1 with 10 VAVs, and I want to high select my 10 VAV temperatures. So the first thing I need to do is I need to put a high select module onto my page. Now all of the control objects that I might want to use are in a palette called kit control. Okay, if my palette's not shown on the left hand side here, I go up to my toolbar and there's an item here called the sidebar. So the left hand sidebar, I can choose to display the palette. And in this case, I'm displaying the kit control palette. If I was displaying some other palette and I wanted kit control, I would drop down the list and choose kit control. If kit control wasn't in my list, then I can go here to the left hand, to the folder icon there, and choose to open a palette. So when I choose open palette, I'm seeing all of the palettes for all of the modules that are in this station. Okay, so in here there will be a kit control module, kit control, and I go OK, and that's the palette that's now displayed. Okay, now if I look in my maths, I've got a max block. Okay, so it's got 2 inputs and a single output. If I right click and go pin slots, I've got 2 more inputs that I can expose for connection. So I can select 4 items and have a single output, which is the high select of those 4 outputs. So inside VAV number 1, I've got my points and my zone temperature, and I want to high select it. So one way I can make that connection is I can right click on my zone temperature and I can link mark. So I've marked the start of my connection, and I go to this module here, I right click, and I got, as well as link mark, I've now got link from or link to. So if I link from zone temperature, I can take the output from the zone temperature and I link it to input number 1 or input A. So now I've got a connection. Okay, I could do the same thing, go to VAV number 2, points, zone temperature, right click, link mark. Go here, right click, link from. Take the output from the zone temperature to input B. Okay. So now I've got 2 connections made. If I click on that one, down the bottom left-hand corner, you'll see the full path for the input and the full path for the connect. So you see the connection details. I can also right-click on that point and go to the link component. In that case, I've jumped to the zone temperature, which is zone temperature points VAV2. If I navigate back, I'm back to the Wiresheet. Okay, so I'm doing this by going to the point that I want, right click, link mark, go to the destination, right click, link from, and joining it up. Okay, and so it goes on. I can do that for VAV number 4. Right click, link mark, go to my destination, right click, link from the zone temperature. The thing that I just marked, take the output, take it as an input. So now I've got 4 temperatures going in and the highest of those 4 temperatures coming out. Okay. Now, if I want to do all that again, I can take my next one, and this time I'll call it maximum for, it's going to be for zones 5, 6, 7. Okay. Sorry. It's going to be for zones 5, 6, 7, 8. Okay. And I'm going to link mark, sorry, I'm going to pin slots for C and D. Okay. Now, last time we went to the zone temperature, we went right click, link mark, but we can also do it the other way around. We can start at the destination. We can right click, link mark. So now I've marked the destination. Then I can go to my first VAV, VAV5, go to the temperature, right click, and I'm going to link to the destination. All right. Get the same view. I'm going from here to here. Okay, that's the first one done. Now this time around, because I've already link marked this guy, I can go here, here, right click, link to, come out of there, into there. Same for number 7, points, right click, link to, come out of there, into there. Okay, and finally number 8, points, select the zone temperature, link to, come out of there, into there. Notice how these are all grayed out because they've already got something connected to them. Yeah, away we go. So there I've picked up 5, 6, 7, and 8. Okay. Now I need one more max block. I can right click and duplicate this one, and instead of 5, 6, 7, 8, I'll call him nine and 10. Okay. So I can select 9 and 10, link mark. Okay. Come down to 9, points, temperature, right click, link to 9 and 10. Out of there into there. Okay. Go to number 10, points, link to 9 and 10. Come out of there into there. Okay. So now I've got all 10 zone temperatures mapped to my 3 max blocks. Okay, so this will be the highest value from 1 to 4. This is 5 to 8, and this is 9 and 10. I can take this output here and feed it into there. And I can take this output here, feed it into there. And now this output is the highest value of all 10 inputs. Now you notice that all of these inputs here, they're all offline. Okay? So they've all got a status of down and stale or fault down stale. So that's because the actual controllers I'm communicating to are not there. So they're offline. And because they're offline, they're not actually included in the high select. And as a result, the high select is null. Okay? And similarly, when I get down to here, the high select is null. Now, just say, if I want to show this working, if I go to my palette, control palette, points, and I get a numeric writable point, and I call it VAV1 zone temperature. Okay, so when I create a numeric writable point, it's like a local variable. Okay, it's an object inside the FX80, but it's got no connection to the real world, or it's got no network connection to a physical controller. Okay, if I double click on it, it looks just like every other numeric writable point, except in the proxy extension folder, there's nothing in there because there is no connection to a field device. Okay, so the only way this point can get a value is if it gets commanded through one of these inputs or through the operator. So as the operator, I can go action set to 22. Okay, I go back, it's sitting there with an output now of 22. So that's VAV zone 1. If I delete this link and replace it with this link, I've now got a reliable input into this high select. So I've got a reliable output. There's a reliable input to this high select, so there's a reliable output. Likewise, if I duplicate this and call him zone 7, VAV7 zone temperature. Put him down here, and I delete that link and replace it with this link. Okay, so now he's got a reliable value that's high selected as 22. We've got two reliables, and we've got 22. If I make this one, if I set the value of this one to 22.3, my output is now 22.3. Okay. So that's high selecting the zone temperatures. Okay. Now, if we want to look at another way we could have done the same thing, is if we go to level 2, we've got all of our VAVs again. We go double click level 2. We view our wire sheet. These are our VAVs. And this time round, if we look in our utility folder for kit control, we have a module called a min-max average module. So if I drag that and put it on the page, and then if I double click, it's got a number of values. Currently that's 2. If I change that to 10 and save it, so 10 is the maximum I can have. So I save that. So now I've got a block that will accept 10 inputs, and it'll give me 3 outputs, the minimum, the maximum, and the average. Okay, so I could go through the same routine, right click, link mark, go to my VAV, points, zone temperature, link 2, so my output from here, input number 1, and same again, work my way down the list, points, zone temperature, right click, link 2, output from there, input there, and so on. So I just worked my way down that list. Because I've link marked the destination, I don't have to keep going back and link marking it again. It's selected and it's done. Okay, so I go to number 3, points, zone temperature, link 2, out, in, okay, and away I go. If I go back up here to the level 1 that I worked on before, so in level 1, those were those 2 dummy variables I put in. If I copy them, go over to my level 2 wire sheet and paste them, there they are, ready to go. If I rename this guy VAV number 4, and I'll duplicate and call him VAV number 5. Okay, so I'm just using these as a way to simulate the real values. So I come out of here, number 4 goes into there, number 5 goes into there, and number 7 goes into there. Okay. Now, one of the things about this is that if there's no connection, then the input is still counted in the high and low select, yeah? So let's just see what we get. If we go to VAV 6, points, temperature, right click, link to, out, in, VAV 7, we've got VAV 8, points, temperature, right click, link to, out of there, into there. Number 9, points, zone temperature, right click, linking to, come out of there, into there, okay. And finally, number 10, VAV 10, points, temperature, right click, link to, out, in, okay. So what have we got? We've got 3 reliable connections, 22, 22, and 22.3. We've got a minimum of 22, a maximum of 22.3, and an average of 22.1. So if the point is faulty or unreliable, then it's not included in the minimum, maximum, and average. Okay, and if we set this value to 25, got a maximum of 25, minimum of 22, and an average of 23.1. Okay. And then if you said, all right, I want to take this high select of my VAV temperatures and I want to reset my air handling unit supply air set point. So typically for that you would use a span routine. And if I look in my palette, I can make that full screen. Let's see, where will I find that? Okay, so I'm struggling to find where that is. So, to get more information on that, if I go to my C drive, JCI, then my FX server, in this case 14.4, there will always be let's go there. So C drive, JCI, then my FX server installation. There'll be a folder called docs, and then under docs there's a series of folders, one for every module. And so if I look here, I find the doc kit control, and under there I find a PDF called doc kit control. Now I'll put that into the chat for this meeting. So I've just copied that into the chat for this meeting, so you can get it from there. But if you have a installation on your PC of Workbench, it should be in the docs kit control folder. Now, double click that PDF. It refers to AX 3.x, but it also applies to Niagara 4. So there's been no change to this in the transition to the Niagara 4. And it lists all of the modules, all of the components in the kit control module. So I'm looking for a span, something called span. What about reset? Okay, so I'm looking for the wrong thing. It's called reset. Okay, low limit, high limit, output, low and high. And it's in the maths folder. Okay. So kit control reset in the maths folder. So I go back to my station. In the maths folder, I've got reset. So I drag him over there and I call it supply air temperature reset. And if I take my high selected value, I can drop it on the white connection, and I can come out of my max and input into in A. Okay. And then if I double click on my supply air temperature reset, I can say when my input is (23 degrees), I want my output, my supply air temperature, to be 23 degrees. When my input is 25 degrees, I want my output to be 13 degrees. Okay, so this is going to span from 23 to 25, gives me an output from 23 down to 13. So if I go back, I've got an input of 25, so I've got an output of 13 degrees. So my supply air set point is 13 degrees. If I want that to actually read degrees Celsius, I can double click here and set up my facets for degrees Celsius. Save that. Go back. 13 degrees Celsius. So if my zone temperature was 24.5, my supply air temperature is now 15.5. Okay. Now, in my air handling unit, so this is all, so minimize this back to there. This is all on my VAVs on level 2. There's my air handling unit on level 2. He's got points and he's got a discharge air temperature set point somewhere. Discharge air temperature set point, which I want to be 15.5 degrees. So if I click here, right click and link mark, and go here and go right click, link from supply air reset. Take the output from my supply air reset and connect it as input 16, priority 16. Okay. So now if I go over to this guy, double click, he's got an input coming in at 15.5 degrees. Okay, that's being sent down to the controller to AV18, present value. It's being written, there's a write command of 15.5 degrees. Okay, it then reads the value back, and because the controller is offline, we get the value 0, which is faulty. So the output still says 0, but the write command is 15.5. When it comes online and that command is successfully sent, the output will say 15.5. Okay, we go back, and now we've also got this little link here. And if you look down, put your mouse over there and look down in the bottom left-hand corner, you can see the details of that link. I can also right-click and go to the link component. And I jump to the destination, which is this guy and that input there. Can navigate back, and there we have it. Okay. If this zone temperature here, action, set, if he goes up to 22.6, sorry, 24.6, my high value goes to 24.6 instead of 24.5, and now the output resets down to 15. Okay, and if we go over to here, we've got 15. Now, an interesting thing is that if I did all this on level 2, and this programming is on level 2. It's in the level 2 wiresheet. On building A. If I right-click on level 2 and duplicate that folder, call it level 3, when I look at the level 3 wiresheet, it's got all of that logic has been copied over. And all of these bindings, if I right click that, it's level 3, go to link, it's linked to VAV1 on level 3 zone temperature. So all of the links have moved and all of the links are correct. Same here for this last link, which should be VAV number 10 on level 3. If I go to link, VAV number 10, level 3, zone temperature. These dummy points that I put in have also been copied over, and they've got their same values, and away we go. Okay. So what that means is, if you can get level 1 done, get all of the linking done, and your wire sheet is inside level 1, on the level 1 wire sheet, when you copy it to level 2, all of those links, all of that automation will copy across with you. And same for level 3. Okay. Now just say all of my VAVs they've got a unit mode. If I right click action, I can enable or shut down. Occupancy. So just say I wanted to enable all of my VAVs on level 1. Okay. So I could go up to level 1, view the wire sheet. Actually, let's go to level 2 because that's a much neater version. So we level 2, we view the wire sheet. Okay, we've got our min-max average. Just say we want to have a numeric writable point, and we'll call it VAV enable. Okay, and I'm going to use this point. I'm going to link mark it. Then I'm going to go to the unit mode for VAV1. And I need to make sure I'm on the right level, so level 2, VAV1, unit mode, right click, link from VAV enable. So I'm coming out of this VAV enable and I'm coming in as a priority 16 command, and go OK. Now this guy here, he's got the values one for shutdown, 2 for enable. Okay. By level 2, this guy here, I need to make sure he's got the same range. So I'm going to have 1 for shutdown, and 2 for enable. Oops, sorry, I didn't click. 2 for enable. I have to click on add, so that's in the list. Then I go OK, OK, OK. So they're my 2 values, 1 for shutdown, 2 for enable. Okay, so now I can right click this, go action, set it to shutdown. If I look at VAV number 1, he's receiving a shutdown command at priority 16. Right click, action, set to enable. He's enabled. Go here. He's receiving an enable command. The enable command is being written at priority 16, but when we read it back, we get 0 because the device is offline. Okay. Now, that's VAV number 1. I can right click this link mark. I can go to VAV number 2. Link from the enable, the output, input, okay. And again, link from, output, input, and so on. So now I've done, if I click on here, I can right click, and I've now got this option for link selection, and these are those 3 links that I just set up. Okay, so that little dot there is actually representing 3 links, which I can select from here. So if I select the middle one, now when I right click and go to that link, I've gone to VAV number 2, and that's the link there selected. If I right click on here, I don't get to select the link because there is only 1 link going back this way. If I go to that link, I'm back here, and I'm back to having 3 links to select from. All right, so this is like a master point. I command it, and I command all of the VAVs that I've linked to it. So I go to VAV number 4, points, unit mode, link from, out to in. Okay. Now if I right click, I've got 4 links and so on. Now what if I thought, so this is just, this enum point has only got 2 states. When I command it, I'm either setting it to enable or disable. Or sorry, shut down or enable are my 2 states. So I could also represent that as a Boolean point. So if I have a Boolean writable on here, and I call it something like enable, and I'm going to use it to command this point. And it's going to be Boolean, so it's got, so when it's true, it's enable, and when it's false, it's disable. Okay, so that was in my facets. Save that. Okay, this guy, he's got enable, sorry, shutdown, and shutdown is the off, enable is the true. So let's go back here and fix that up. Instead of disable, we should have shutdown. Okay, save it, go back. Okay, action, set to shutdown. Okay, so he's sitting there saying shutdown. If I take this output out of here and I stick it into there, it lets me make that connection, but it just set the value to 0. Okay, because false is 0. If I right click and set it to the true value, which was enable, go OK. It's now true, which is enable, which is the number 1, which is shutdown. So we've got a problem. This Boolean point is going from 0 to 1, but we require it to go from 1 to 2, because 0 is not a valid number for this enum writable. Okay, so how do we do that? First of all, we'll delete this link. So we need to convert true and false to an enum value. So when it comes to those conversions, there's a folder in here called utility, and it's got a module called enum switch. Okay, so anytime you see switch, it takes a Boolean input and it switches between 2 possible values. Okay, so there's a numeric switch, so we'll leave the enum switch there. There's also a numeric switch, and there's actually a Boolean switch, which may or may be useful. So we take the output from here and we put it into the switch input. And just for, we'll put it into so the way the enum switch works is when it's true, I want to put the value 2. When it's false, I want to put the value 1. Okay. And my facets, if I want to, I don't have to set this, but I can set it to that so that it now makes sense, because 1 is shut down, 2 is enable. Save that, go back. So the input is true, the output is enable. So I can make a connection here. So now enable gives me enable. Right click, set it to disable, or sorry, set it to shutdown, which is false. False gives me shutdown. Okay, but the actual value that's being sent there is the number 1. Okay, so this is switching between two values. Enable is 2, shutdown is 1. If I set up my numeric switch, I could set up my true value to be 25, and I could set my false value to be 20. So it's false, so I've got the value 20. If I set it to true, which is enable, the true value of 25 now gets sent out. For my Boolean switch, when the input is true, what do I want the output to be? Let's say I'll leave the output as false. When the input is false, I want the output to be true. I'll do that. Save it. Now, the output is just the opposite of the input. Okay, the input is true, so I'm sending out false. If the input was false, I would be sending out true. Okay, so that's an enum switch, and that bit of logic there is very important. Okay, so as a general rule with BACnet, when we use a lot of enum points, enum writables, or enum inputs to represent what's underlying is Boolean values. So it's either on or off, true or false, but they map to the values 1 and 2. So 1 is off, 2 is on. Okay, so if you ever have to switch between Boolean to enum, you use an enum switch. If you wanted to go the other way, take an enum and turn it into a Boolean, then for that you need to go to the select folder and choose a Boolean select. Okay. So the way the Boolean select works is you have an input that goes into the selector. And in our case, there are two possible values. If it's a zero-based select, if that was true, then it would be values 0 and 1. But because zero-based is false, the two values are 1 and 2. So if it's 1, we want to have an output of false, and if it's 2, we want to have an output of true. And if we refresh that, I've got myself in trouble here because I've changed two things at once. So let me refresh and don't save my changes. So first I'll change that from 3 to 2, save it. Oh, sorry, it won't let me go below 3. So I'll leave it at 3. So if my input is 1, I want the output to be false. If the input is 2, I want the output to be true. And if the input is 3, I also want the output to be true. Okay, save that. Go back. So my output here is what matters. If I duplicate this guy, I put that over there and I take the output from here, put it into there. And if everything's working right, when I change this, I'll change this. So I right click, action, set to shutdown. Okay. And my back to Boolean is shut down. So this one turns it into the value 1 for shutdown. This turns it back to the value false for shutdown. If I set this to enable, which is true, if I set it to true, this sets the output to the value 2, and this selects the value 2, which is true, and we're back to enable. So this bit of logic here is something you might need to do occasionally whenever you need to switch between enum values and Boolean values. Okay, so thing to remember is that the switch has an input that is either true or false, the in switch, which is true or false, and it selects between two possible values, the true value and the false value. The Boolean select takes an enum as its select input, and it can select for the different states of that enum, starting at 1, 2, or 3. Okay. So far we've been working underneath our backnet network, doing our automation down here so that when we copy level 1 to level 2, all of that automation work goes with it. Okay. Another place we can do automation is under the Facility Explorer folder. So we have drivers, then we have Facility Explorer, then we've got Custom Control, and in here we can right-click, View the Wiresheet, and we've got a wiresheet where we can do any sort of control we like, and it's not particularly associated with a folder underneath a backnet network. Okay, so we're just going to use this as a way to go through and show you the various different objects that are in the palette. So starting at the top of the palette, we've got folders. Now remember, every one of these objects is listed in that document called Kit Control. So this document here and it's got a table of contents where they are all listed alphabetically. So you can, if you've got any particular object you want to find out about, you can choose it here and it'll take you to that, the description of that object. Okay, so if we go back to here. So control palette. This is where if we need to put a variable onto the page, like a local variable, we can get it from here. So our choices are Boolean writable, numeric writable, and enum writable, enum writable, and we've also got a string writable. Okay. So the Boolean point, numeric point, there's not much use for these, because if I put one of these on here, like the numeric point, it's got an output, but it's got no way of setting that output. All right. So I can't set the output. It's just sitting there at the value 0. I can't give it a value. I can't do anything. So numeric point is not much use to us. Okay. So numeric point, Boolean point, enum point, and string point are of no use. You want to use the writable version of the 4 point types. Okay. So they all have the same thing. They all have facets. So for a Boolean point, the facets define what you display when it's true and what you display when it's false. So if somewhere in here I've got true is on, false is off. So I save that. If I refresh it, it's currently got a value null because nowhere is there a valid value for this output. So if I set the fallback to off and save it, it's now off. Okay. There's a minimum active time and a minimum inactive time. So minimum on, minimum off. So that would, if I set this to 20 seconds, it would mean that if I turn this on, it's going to stay on for at least 20 seconds. I can't turn it off inside that 20-second period. Likewise, the minimum off time, if I set that to 30 seconds, it means that when I turn it off, I can't turn it on again until 30 seconds has expired. And do I want to have those timers set when the FX80 first starts up? So in this case, I'll say false. Okay, so that's my Boolean writable. He's got the 16 levels, 16 inputs for the 16 different priorities plus fallback. Okay, if I go and look at my numeric writable, the same deal. I've got facets, and that determines what units do I display and what precision do I display the number at. So my units I can set to, find here, temperature, QRST, temperature, degrees Celsius, okay, with 1 decimal place, okay. I can save that. So now when I refresh it, I need to give it a value. So if I give it a value of 22 and save it, it displays 22.0 degrees Celsius. Change that to 5, save it, 22.5. If I change the precision to 0 decimal places, go OK, and save it, and refresh it, it now displays 22. Right? If I set the value to 22.6, save it, it goes to 23, and it displays 23 there, not 22.6. If I change this back to 1 decimal place, go OK, save it, refresh it, now displays 22.6. Okay. Same for my enum writable. An enum point has a range, and the range sets the values. So I can start at 0, go off, one is low, 2 is medium, 3 is high. Okay, okay, okay. So low, medium, high. Save that. Now when I set my value, I can choose off, low, medium, or high. So if I go medium, save it, the output is medium. But what the output really is, it's the number 2. Okay, so if I take that out of there and connect it into there, take my output from here and my input to there, it doesn't like it because I'm connecting an enum to a numeric. Okay, so it doesn't let me do that connection because The 2 points are not valid. Okay, if I come out of there and into there, it did let me do that. Oh, sorry. Let's delete that connection. I come out of there, into there. It's put in the value 2. Okay. If I come out of here and into there, it's put in the value 0. Okay, so Boolean, as it goes from true and from false, it's false at the moment. I set it to true. It goes to the value 1. My enum writable, when I set his value to high, I'm setting it to 0, 1, 2 to 3. So the value 3. Okay. Break those connections. Okay, and then the last one is string writable. And this one, I just get to and so in this case here, it's the output is write a string. Okay. So the useful thing about this is you can put that string variable onto a graphic and it'll display whatever you've got in here. And you can have logic that changes that value, just like you have logic that changes numeric and Boolean and enum points. Okay. So they're the 4 point types: Boolean, numeric, enum, and string. This is all in the control palette. Points. Extensions is where it lets you set up totalization on those points if you need to. And trigger lets you trigger this control loop or have something trigger via an interval or via daily. Okay. Next in the control palette is alarm, and these are alarm extensions specifically for special types of objects. So the elapsed active time alarm extension is if you wanted to set an alarm when a unit had been on for, so if you had an hour's run and you wanted to set the alarm for when 100 hours has elapsed, you could use that to set up an alarm for 100 hours runtime. And then you might go and do maintenance on that device. So if, same for change of state. So if you were counting the number of starts, so just say a chiller after 100 starts, you need to go and do a certain amount of maintenance, then you could set up an alarm extension on the start count. the alarm count to relay, if I put that on the page, and then here it will count the number of alarms that are currently in the system. Okay, and it will turn the output true when there's any alarm or any unacknowledged alarm, or open alarms, or in alarm, or total alarm. Okay, so this would be my limit. And if I want to see when the output comes on, I can pin that output. Constants. So a Boolean constant is very similar to a Boolean writable, except that all I can do is set the value to true or false. It doesn't have all of the 16 input priorities. All it has is the ability to set the output to either true or false. Okay, and from there, so I can take my Boolean constant and I can use it to drive a Boolean writable. Same for my numeric constant. I can take his value and put it into there. I can right-click, action, set the value of the constant to 22.3, and he changes that. Same for enum constant. I go in here, I can set my range to the same ranges that I had before. Save it, go back, put that into there. So now he's off, change this guy. Set him to medium. He changes to medium. And similar for the string constant. I can set the value of the string constant to hello. I can take that and put it into there. So currently the value is write a string. Now it's going to be changed to hello. Okay. So constants, conversions. So these modules let us convert, in this case, a Boolean to a status Boolean. So this Boolean writable has got a value and a status. So the status is OK at priority 16. Okay. So the value is off and the status is OK at 16. Okay. If I take that as my input, if I now set it to true, he goes to on. This input is true, the output is true, and it's okay. If I break this connection, my output is still on because I've got a fallback. If I set that fallback to null, my output is null. But because the last value was true, this one is still true and okay. Okay, so this is looking at just the state of the input, not the status of the input. So if I now set this to false, is false and okay. If I set him back to null, I didn't, oh no, up here is set him back to auto. But he's still false. Okay. So similarly, so double is a numeric, enum to enum, float to numeric, integer to status numeric, and so on. So these are just converting values and either keeping the status or removing the status. And the last one is just changing the units, say from degrees Celsius to degrees Fahrenheit. Okay, so that's your conversion folder. Next one is the energy folder. A useful one in there is the optimize start stop module. So if we create a folder under our custom control, we have a new folder called optimal start. And we put our optimize start stop module on there. Now, for our optimized start stop, we need to have a schedule. Now, the thing about the optimized start stop is it's a true false output. Okay, so it's working, it's driving a Boolean point. So we'll have a Boolean writable called our unit start. And we'll need a schedule So to get a time schedule on here, we go to our palette and we choose schedule, and we choose a Boolean schedule, and we'll call it the occupancy schedule. And the two states of my schedule will be true will be occupied, and false will be unoccupied. Okay, and I'll save that. Now when I go to my weekly schedule, I'm unoccupied, then at 9 o'clock on Monday through till 5 o'clock, I'm occupied, and I can apply that Monday to Friday. Okay. And I save that. So here's my occupancy schedule. Currently it's occupied because we're between 9 o'clock and 5 o'clock. Okay, so the schedule status, I come out of my schedule and into there. So the schedule is currently true. Then we're saying the next event time is 5 o'clock tonight on the 26th of April. And the next value is false. So it's currently true. At 5 o'clock tonight, it'll switch to false. Okay. Somewhere out in the system, I'll have an outside air temperature. So I can simulate that by going back to my kit control palette and having a numeric writable called outside air. Okay. I'm going to set that to 25 degrees. Come out of there, outside air temperature. Similarly, I'm going to have my zone temperature. Zone temperature in the space. And he's going to initially have a value of 23. Okay. Comes out of there, into there. So normally my occupancy schedule would command my unit to start or stop. Okay. So turn the unit to on or off. So when it's occupied, the unit starts. Okay. when the optimal start wants to start the unit, we'll come in at priority 14. And when we want to stop the unit, we'll come in at priority 15. Okay. And inside here, so I double click, I'm looking at the property sheet of the start stop module. Somewhere in here, I set up my comfort temperature limits. So we're working in degrees Celsius. So if the temperature is less than 23 degrees and more than 20 degrees, they're my target comfort limit. So at occupancy time, I want the temperature to be between 20 and 23. Okay, and I'm going to allow optimal start and I'm going to allow optimal stop. Okay, we're all good to go. So my space temperature is currently 23 degrees, which is inside the comfort band. Okay. If I change my schedule, so right now the time here is coming up to 2 o'clock in the afternoon. So if I change my occupied schedule to 2:30 and save it. So the unit is turned off. The next start time is 2:30 and the next event is true. So we're going to start at 2:30. And it will calculate when it needs to start in order to achieve conditions by occupancy time. So right now the space temperature is 23, so the space temperature is acceptable. But if we and the other thing we need to look at here is the heat cool mode. So we want to use cooling. So if the space temperature was 27 degrees in the space, it now does the calculation, how much earlier do I need to start the fan in order to move that temperature from 27 down to 23 by occupancy time of 2:30. And it's put a message there, this message, which I could put into a string writable. So I can take this message, put it into here, take the message, connect it to there, go OK. And that string is saying optimize start for that. Space temperature is 27 degrees. And it's already switched on. Okay, so it's worked out that in order to get the temperature down to 23 degrees by 2:30, it needs to be running the fan now. So the start command is on. The unit is running. Okay. Okay, so that's optimize start stop. Okay, so the main thing is that you'll have a schedule that's true or false, and from the schedule you've got the current schedule status, which is the output from the schedule. You've then got the next event time and the next event value. Okay, then coming out of your optimized start, you've got the schedule itself commanding the output at priority 16, and then you've got the start command at 14 and the stop command at 15. So right now the schedule is saying off, but the optimal start is saying on at priority 14. So that's the value that gets switched to the output. Okay, when schedule time comes around, the occupancy schedule will switch to on, and the start command will go to null because we're no longer in the optimal start period. Okay. So that's optimal start, and that came out of the energy folder optimize start stop. Okay. Looking in the HVAC folder, there's quite a few useful options. One of them is the interstart delay master and interstart delay control. So these two objects work together to provide you with, let me see if I can find a, yeah, so this is an example. I've got a single start point and I want to control a series of outputs. Okay, well, I don't want them to start all at once. Okay, so each one of these outputs here is the interstart delay control. And in here, it's got the normal inputs that you expect for a writable point, but it's also got a delay of 5 seconds. So what that says is that if I start this output, no other output can start until 5 seconds later. So, and that I've got that same setting in all of these. So at the moment, all of these are on. I command them to off, and they all turn off. Okay. They all have a minimum off time of 20 seconds. So when they turn off, they have to stay off for at least 20 seconds before they can start again. And when they do start, they must stay on for 20 seconds. And they've all got this 5-second delay. If we go back, by now, command them to on. Okay. The first one is on. The second one is off. They're all off. The second one is now on because the 5-second, this one is on. 5 seconds later, we expect this one to come on. 5 seconds, expect this one to come on. Yep. And finally, this one, after 5 seconds, it comes on. So it means that the 5-second delay for this one means that nothing else can start until his delay is timed out. And then the next one in the sequence can start. Okay. They all share a master start delay module that groups them all together. And so typically, if you had a series of large electrical loads like big exhaust fans or big supply fans, and you don't want to start them all at the same time, if this first one takes 5 seconds to run up to speed, once it's up to speed, you can then start the next one, and so on. If they're all fed from the same feeder, then they should all come under the same master delay module. And in here, there is a reference to that master delay. Okay. So if I were to add one more interstate delay control in here, take his output from there, put it into there. We double click on here. He doesn't have a master defined. And he doesn't have a delay defined. So I'll change his delay to 5. And I'll choose his master, which is underneath Facility Explorer, Custom Control. Where was it? Interstart delay master. Okay, save that, do that. So he's true. Action, set him to off. Okay, he's gone off. Right click, action, set him to on. They've all been commanded on. He's come on. Nobody else has come on because they've got that 20-second minimum off time. So now he can start. 5 seconds later he starts. We're expecting this guy to start. Now him. Now him. and so on. We're all running. And our master active delay is now false because everything is started as we'd expect. So that's the interstart delay control. The lead lag cycles module, put that on the page. If you had, say, three pumps, but you only needed to run one pump at a time, you take this output out of here, feed it into there. When it's true, one of the outputs is true. Okay, and if we don't get status come back in time, we get an alarm. Okay, so we would have pump 1 status. And then we could have an OR block. Okay, so we've got our 3 pumps. When we start them, we'll get the status that says they're running. So let's go back over here, right click, action, set it to off, and our pump turns off as we'd expect. We right click, action, set into on, and pump number 1 comes on again. The feedback is true and everything's good. We right click, and set him to inactive. we get an alarm. Okay, because we don't have our feedback. Now these cycle count inputs here, they're the number of times that the output has been started. Okay, so if output A has 10 starts, output B has 2 starts, output C has 3 starts, we go back and we set the value to off. And we clear the alarm. Okay, and we'll take this override off. Okay, so output B has got the least number of starts. When we right click here, action, set him to on. We've still got output A come on. That doesn't sound right. Going to need to check on why that didn't work how I expected it to work. So I'll have to check that one and get back to you for that. The rest of these modules, you've got there's a folder here for logic where you can do and or, exclusive or not. So you can do all of the logic that you need. There's greater than, less than, and so on, and equal to. In the maths, you've got absolute value. You can add, subtract, divide, multiply, and so on. selects we've talked about already. In the string section, you can use these functions to come up with different, to manipulate strings like bits of text. So you can add two strings together. You can get the length, you can get a substring and so on. You can compare two strings, you can remove the blanks off the end. In the timer sections, you've got a delay timer. This gives you an on delay and an off delay. You can have the current time or a one-shot timer. You can calculate the time difference between two times. And then utility. One of the useful utility items here is a sine wave. So if I go back up to my custom control, I've got a sine wave here that gives me just a continually varying point. And if I look at the history of that output, you'll see what I've got there. So you can generate a varying value so that you can simulate right. So that's the control palette for Wiresheets and for doing automation within an FX80 or within an FX server. We've sort of gone over time a little bit, so I'll leave it at that. I'll go away and find out why this lead lag module wasn't doing what I expected, and I'll let you know probably tomorrow what was going on there. So is there any questions on any of that? Okay, so one of the things is, would those global points add to the total FX80 points? So I assume you mean these Boolean writables that I've added in here. They don't count as points. So the reason they don't count is because they don't have a proxy extension. Okay, so the point count that matters is the points underneath our backnet network, underneath our backnet device. All of these points in here, if I look at the property sheet, all of these points, they all map through the network. They're coming through the network from a device in the field. If I add look at the wire sheet for this controller, all of those points are included. But if I add a numeric writable, okay, so that I can take the output from here and put it into there and do something with it, this numeric writable is not included in the point count because the point resides inside the FX80 and there's no proxy extension mapping it to a field point. Okay, so it's only field points that matter from a licensing point of view. Okay, yeah. So is any other questions?
Yeah, I've got a few questions.
Yep.
Let's say if we want to map, and in the wire sheet, we want to do a logic control in one FX80 based on a point from a different FX80.
Yes.
So do we just do the mark thing and then use the nav and link to the other point?
So, yeah, so the question is if we had some, just say we had to get the outside air temperature from a different FX80, okay, so it is actually a little bit complicated. So what we do is we have our drivers, and then in our drivers folder we have our Niagara network, and under that we have another FX80 out there that we've connected to. So I'm in this FX80 has gone out and found this particular FX80, and what I need to do is go in here and discover the points inside that FX80, and there I've managed to find a point called, there are no points to discover. It's a bit of a problem. Yeah, so if there was, that one might do us. Let's add that point. Okay, so we add a point. So this point is now being mapped out of that remote FX80, and its current value is 0. Okay, so now I can then, if I rename that to be master outside air temperature, okay, it's currently 0 degrees coming from that remote FX80. I could then take this link mark, go down to my custom control, optimal start, go in here and say, this is my outside air temperature. I can link from master, to come out of my master and into my, so now this is being driven by that remote point. Okay, so I'll cover that in a little bit more detail when we do the Niagara network module.
Do we consume any license when we connect one FX80 to another, or it's considered a Fox point?
That's right, it's a Fox point, so it's free. There's no limits between FX80s. The only time you use connections from a licensing point of view is when the FX server connects to an FX80. Each time it does that, it's using up one of its Niagara connections, but the number of points that it can draw through that connection is unlimited, or it's just basically limited by the number of points that are in the FX80.
Right. I've got another question.
Yep.
Let's say in the Wiresheet you want to do a logic based on a specific date and time from a trend.
Yeah.
Is that possible?
So
let's say you want to get a monthly consumption for kilowatt. Yeah.
So you want to, yeah. I don't think there is a way to do that. I'll have a bit of a look this afternoon and see if I can. Yeah, I'll need to go. I'll need to check if there's a way to do that. Yeah.
Yeah, because sometimes customers ask, can they get the weekly consumption or daily consumption, you know?
Yeah, yep.
Just need to know how we can display that data in FX.
Yeah, yep.
And I've got another question. Is there any way to know what is the total points being used in the system at any one point of time?
So if we go to the station itself, yeah, so when you're up at the station at the top of the top node in the station and you double click, you're seeing the station summary, and you can also change that to the resource manager view, which shows you your CPU, memory and resources and so on. And in here is a component count. So that's the number of objects or number of components that you've used. Okay. If you want to get the point count from a licensing point of view, I think you need to go to, it's a little bit tricky, you go SPI local, I think it is. No, I'll need to come back to you with the answer to that. There's definitely a way to do it. I just don't have that in the front of my mind at the moment. So, yeah,
yeah, sure. So
take that
I'm
one on
good.
notes, yeah.
Yeah, I'm good. Anybody else has any questions?
Okay, so that's pretty much it for today. So I've put the kit control document in the chat. So if you want to, you can get a copy from there. If you have a look through that, and if there's any questions on any of the objects that we didn't talk about today, then either send me an email or ask in the next few sessions, and I can go back and cover that if required. Okay, so thank you, and tomorrow we will be looking at graphics. Okay, so tomorrow is another big topic, graphics, and then Thursday we'll do point extensions, alarms, trends, and so on. And then finally on Friday we'll do the Niagara network. Okay, so thank you for your time today, and we'll be back same time tomorrow. Okay, thank you.
Thanks, David.
Thanks, Sri.
Thank you, David.
Thanks, Jing.
Thank you, David.
Thank you.